Welcome in the fourth section, GPU distributed training and CNN. Often when you try to use and learn about deep learning, you will see that there's a lot of friction concerning GPU programming. Instead of using standard CPU approach, you can use GPU. In this section, we'll try to understand why to bother, why to use it, and when we should use it, and what does it give us, and why GPU is really well paired with our deep learning approach. So we'll start from understanding basics of GPU. In this first video, you will understand what the GPU is and what does it gives us. Next, we'll be performing parallel training with multiple GPUs. So we'll see how to leverage the fact that you have GPU in your CPU and how to speed up your calculations using our API. In the third video, we'll be designing a basic CNN. So at top of the knowledge that we will learn throughout the first and second section, we'll be able to solve a real actual problem using deep learning approach. In the last section, we'll implement that CNN in Deep Learning for J framework on Spark, understanding basics of GPU programming. So firstly, you will understand why to use GPU with deep learning. What does it give us? You will see why it can be better than using standard CPU, why this approach sometimes can be better. So let's firstly recap why GPU and deep learning is good together. So GPU is just the heart of deep learning applications. The improvement in processing speed is too huge to ignore. So what GPU gives us? It has good cost performance. So comparing to performance that you will achieve using standard CPU and memory approach, when you will use GPU, it will be more cost effective and also you will achieve higher performance. GPU has enough of memory. GPU graphic cards tend to have a lot of memory that is very fast and could be leveraged to our deep learning models. Also, it has good cooling. So if you have a lot of GPUs that works 100% time, it is easier to cool them down than standard CPU approach. If you are building your cluster, recommendation is that each GPU should have at least 4 to 8 GB of RAM. So how does it work? So you have one CPU, then you have PCI switch and multiple GPUs. So CPU can route the traffic to the PCI switch, and PCI switch can leverage the fact that you have multiple GPUs and make your operations parallel using one of them. But why GPU machine learning is so fast? They are fast because they are efficient in matrix multiplication. In the previous section, last video, you saw that the main construct of our deep learning algorithms is matrix and IND for J array. This is a construct that allows us to do scalar multiplication, subtraction, and so on. You saw that we can add two matrices together, for example. To do so, we need to have really a lot of memory and good memory bandwidth. So the real reason for this is that memory bandwidth. Parallelism is not as important as memory bandwidth. So let's compare and see GPU pros. First one is high bandwidth with main memory. So CPU is good at fetching small amounts of memory quickly. So if you have couple CPU instructions like fetch data, send IO request, and so on, this is very good for CPU. It can fetch small amount of data very quickly. But if you need to fetch large amount of data into memory, like for example matrix has a lot of data in it. If you have matrix with 100,000 columns, 100,000 rows, and even more dimensions, it will be a lot of memory. So GPU is better for fetching that amount of data. The best CPU have about 50 GB per second memory bandwidth, and best GPU has 750 GB per second memory bandwidth. So we can see that there is a huge difference, more than 10 times factor. And this is because GPU can fetch a lot of data simultaneously. Second pro is hiding memory access latency under thread parallelism. So GPU has a lot of threads that process chunks of batch. Every thread has associated part of memory to process. So you can imagine it as a big chunk of memory, split it into smaller chunk, and every thread processes only small amount. In a standard CPU architecture, it is a bit different. Third pro is large and fast registers and L1 memory cache. So GPU can have a batch of registers for every processing unit. Also, GPU register size combined is more than 30 times larger compared to CPU registers. Registers on CPU are fast but small. So, comparing, GPU operations are executed at speed 80 terabytes per second, and CPU operations are executed at speed 10 to 20 terabytes per second, so threefold speed up. CPU registers usually have size of 64 to 128 kilobytes, and GPU is 30 times larger. That's why we have that execution speed faster.